So that's why I'm not gonna give a quiz today, because I know that some students might be busy helping their family or friends or whoever, or even evacuated. That's why there will be no quiz today. We'll just talk about hypotheses and test them, and that'd be all we need to practice with. So last time we had a little quiz, and the exercise I asked you to do was related to problem number 6, was it? I just wanted you to set up the little hypothesis there. I think it was number 6 exercise. So it's talking about a claim that the temperature is less than some particular number. So again, I'm looking at exercise 6 right now. And it says the temperature, and actually the word here is mean. So I put a mu, right, in the claim. And that mean is less than 98.2. Okay, 98.2 is what I'm comparing it with. And now I have to decide, would that be H1 or H index 0? And the answer will say there is no equal sign, so it must be H1. So that was a quiz from the last time. So I wanted to make sure that you put that claim into H1. I'd like to actually take a problem and do this problem entirely. Maybe not exercise 6, but something with a story, so one can better see what is going on, and that could be, I guess, more exciting. So let me see, how about the exercise number 15? So they want to compare the forecasts for high temperatures in here. So what's happening here, they want to see the differences in between the actual temperatures and what they forecasted. So they looked at number of differences, which is equal to 31. So that's a sample size, n, right? 31. And notice that the mean for that was something like a negative number, which is minus 0.419. There's a mean for this sample, x bar, and a standard deviation, which is 3.7 something. So that's a sigma, 3.704. That's our start here. And the question is, does this appear to be close or not? What does that mean? Well, we're trying to see the claim, if it's accurate or not. So the question is claim that mean is equal to 0 or not? Why 0? Well, because if there is no difference in what they forecast and what happens next day or so in reality, well, then they make an accurate forecast. But if there is a difference, well, depends how far it is. So if it's close enough or not. So if you prove that there is pretty much no difference, then their forecast makes sense. And if you prove that there is a big difference, then the forecast is a waste of time. So I guess that's the key part in this exercise. And we have a good start by placing our claim in H index 0. And the opposite will be not equal, right? Because must be with equal sign always for H0, so not equal, which is either less than or greater, would be less than 0 or greater than 0. That's our H index 1. So I will be making a favorite picture here and place the H1 in 2 regions, remember, because this is either greater than or less than. So if my mean is in the center, question is, are we in H index 1, the alternative that says no, it's not equal, or we're in H index 0, which is what's in the claim. So the question is, what is the level of significance that we want to use in this particular problem? And looks like they don't really have one. So since they don't tell me what level of significance is, I take 5%. That's a standard. If you are not given significance level, then it's 5%. So you break this into 2 equal regions here because we have 2-sided test, and each is going to be of the area of 0.025, which is 2.5%. Right? Break the 5% in 2 equal pieces, and then the z-score that will cut out this from my whole region will be opposite because 0 is in the middle and the picture is symmetric with respect to that center point. So I will go to the tables and try to find 0.025 in it, and it's there. 0.25. You start to go down from the top, you will eventually reach 0.025 right here. And that gives us the z-square, if you put together minus 1.6 and 9 hundredths, you get a 1.96, positive and negative because it's all symmetric. So we have a start for the exercise, and now we need to get a z-square. And we use formula that we always utilized, x minus mean divided by a standard deviation. And the standard deviation we put over square root of n because we have a sample size 31. So let us put the numbers in. The x value is given to us here, negative. So we don't really care what numbers are. We just want to put them all in the calculator. So when we able to calculate, we'll see if it's H0 or H1. So that's the same process for all of them. So instead of mean for population, I use what's in my hypothesis, which is here. So mean is equal to 0, so I put 0. For standard deviation, they also gave us the number 3 in an assumption, 3.704, which I have to divide by a square root extracted from sample size of 31. So now I need to be careful with this numerator and denominator. We always use parentheses. Of course, you don't have to subtract 0 because it's just going to be the same thing, right? But you want to be a little bit careful and try to get all that entered correctly. So let us do this. Minus 0.419 is here. And this is going to be minus 0. Well, you can put minus 0 if you want, makes no difference, still same thing. And then again, I divide by parentheses that has 3 and little something, 704 divided by a square root 31. Right? Square root 31, just like that. So we got some type of a z-score. Please notice this is a very low z-score, right? This is kind of unusual. So what does that mean? So 3.5067, etc. So where is the z-score in our particular picture? Oh, I didn't put square root from 31. Thank you. See, I need to wake up. I appreciate your double checking this because otherwise the answer would be definitely not correct, right? So let's put that like that, and then I delete. See what is going on. I wasn't careful, I think. I put divide by square root from 31. Okay. See, you're already better than I at calculating those z-scores. So let me erase that stuff because there's not enough room here. So here it is. Okay, thank you so much for double checking. And we got a negative 0.629 ... So this is our z-score that we have to now place on that x-axis and decide where is this line at, and looks like it's here someplace, right? Minus 0.6 or 0.62 ... is in the area called H0. So I say yes to H0 and I say no to the opposite. And since yes is given to H0, my claim was supported. So the forecast is correct. Please notice that I was not carefully calculating it and I would have produced completely different answer. So just one little misprint in the calculator could give you the opposite result. And that will be definitely not too good. But I guess thanks to you and thanks to the calculator that enables us to see what we actually enter in here is very, very helpful, right? So that's the idea of the exercises. And here we can claim just about anything. And then find a z-score and it will tell you yes or no to the claim. And this is the plan. So I'd like to follow these ideas and now return back to the previous section, 7.3. That has exactly the same plan, but it deals with so-called population proportion. And sometimes, like say today, when people be voting, what would count is not a mean of votes. It makes no sense to talk about the average vote, but it makes sense to talk about the proportion or percent. Who's got more percent? Who's got 50% and somebody got 40%? So the higher percentage wins. And that's why in some cases, like in section 7.3, it makes sense only to discuss the percent, P, or proportion. And that's why there is a little different formula to find a z-score. So you use z, P with a little hat. It's like a sample mean we had with a X bar, right? So with X bar, we have sample mean, and P with could be bar, but they like to put hat, is a sample proportion. So when it makes no sense to talk about mean, we can talk about proportion. We use this little formula to calculate z-score in the case of proportion. So let us take a look at problems in this section, so you will see that it really makes no sense to talk about the mean. but only proportion is here. So let's say, how about problem number 5, exercise that deals with percentage of people that using emails. Well, remember it's year 1997, so it's been a while ago. So they say they surveyed 880 households. So now I'm in the section 5.3, looking at page 427, and do exercise number 5. So we're dealing, so that's 7.3, right? Sample size of 880 with 149 using email. So actually out of 880, 149 were using email. So I can say P, or proportion of people that used email those days, was not that big. It's 149 from 880. Okay. So we need to use this sample to test the claim. That's our new favorite word, right? So what do they claim? They say that more than 50%. So the proportion of people that use an email is more than 0.15. So we always write percent with letter P. And that's our start. So I have to bring this claim into H index 1, right? Because H0 is supposed to have equal sign, which is going to be in the opposite to this statement, because the opposite with to greater will be less than or equal, right? To 0.15. So that's the opposite. And now we have a good start to make a one-sided picture here, because we just care for the greater. So always make a picture of that H1 first. So greater is someplace here on the right side. So this is the region that corresponds to my H1, and the rest is H0. And there is one more piece of data here. They say use 5% for level of significance. So the area of this region will be 0.05, 5%. So it looks like just like in the previous exercise, we have a standard start, but now I need to utilize 95%. Because I need to get area on the other side. Remember, we always try to get that area from the left, because tables give us area from the left. Because when you look for 0.95 in the tables, you will actually not find it there, but the arrow, remember, where the encountered this once, because 95% is in between 9495 and 9505. So it has to sit right there because it's exactly in between. And that's why we have to use for area of 95% to the left a z-score, which is 1.645. Okay, so we'll use that cutoff z-score to get everything calculated, and everything will be calculated using new formula here for z-score. The only thing that I miss so far is Q, because P we utilize what's given in the claim, and Q will be the complement of P, remember? So this is 1 minus 0.15 or 0.85. 0.85 is here. So I have both P and Q. So I'm going to put them in my fraction. So I already know the sample proportion P with a hat. This is 149 out of 880. I'll just put in the calculator the way it is. I'll let the calculator work with it. Then the population proportion was 0.15. That's a P without any hat. And now I need another fraction in denominator. P and Q. 0.15 times 0.85, right? Divided by sample of 880. This is what I need to put in the calculator. And I also want to put parentheses around my numerator to make sure that it's done nicely. So let's do this here. So please double check, make sure I don't miss enter anything. So 149 is on the top of this, divided by 880. Now I bring this cursor next to the fraction and minus 0.15. 0.15 like that. So that's a parentheses. And now I'm going to denominator and put a square root. And inside the square root, there'll be a product of 0.15 with 0.85. And then divided this by 880. Now you say, why 0.15 is not divided? Well, actually 0.15 is multiplied by the fractions, so it goes into this fractions numerator anyways. So it is in the numerator, it is on the top. So you don't have to put parentheses, but if you want to, you can try. It'll be the same thing. So I'm getting z-score, and the z-score is 1.604. Look at that, it's pretty close, right? It's a number which is still right here, right? Because that's 45, and here we have just 0.4, so it is a little bit less than in the particular 1645, but it's pretty much on the border. But since it's in the H0, I'm gonna say yes to it, because I hit area called H0, no to H1. So to the claim, I got the answer. I simply rejected it. So I'm saying that it's not true that in that year, 97, more than 15% of households had their email. So we made a test. So those days, I guess, no more than 15% of people were using email, and I guess nowadays this changed, right? But you can see how much this was in year 97, according to exercise number 5. So this section is talking about claims related to population proportions, and all of the exercises here are of the same type. And my goal was to show you that this section is not really any different with the previous. The only distinction was in how we calculate those z-scores, because here they just gave us a little differently looking formula compared to our favorite formula where we used all this means divided by standard deviation over square root of n. So here is a little different formula for calculation, but the setting for the whole thing is really pretty much the same. So it turns out that we are going kind of backwards here. So we're in chapter 7, which I jumped into after skipping chapter 6. So what I plan to do next time is to return back to chapter 6, which I think is exciting chapter, but chapter 7 is definitely very useful, I think, for various tests you could come up with, because technically in this previous exercise, somebody could claim it was more than 15%, and your hypothesis test said, no, it's not correct, but somebody else could say, I think it was less than 15%. And you said same exact process and it would be supported. So you would actually prove that it's not more, but less than percent. In other words, it doesn't matter what somebody claims because you either accept it or do not. So if you accept that claim was correct. If you don't accept it, you actually show that the opposite statement is correct. So somebody who claimed the opposite would be correct then. So there is really always either one or the other, which is correct because they're complements. I'm talking about H0 and H1. And this is the idea that we need to get used to in this chapter 7. So section 7.2, I disregarded, but not really, because it's all talking about this H1 and H0. So doing problems from section 7.3 and 7.2, we actually 7.3 and 7.4, we actually did problems from 7.2. So I think we're good in chapter 7, but of course it needs more time for you to think about, and I hope that you will do the same problems, number 15 from section 7.4 and number 5 from section 7.3 that I just done, and maybe try another problem in 7.3, because next time I want to do, of course, another problem in 7.3. So give you time to adjust and get used to this hypothesis setting procedure. And then we'll go backwards to the previous section. So today I don't give a quiz. I already told you that I know some people might be preparing to this hurricane, and I don't think I should downgrade anybody because of that. That's totally unfair. So maybe you also want to do some preparations, whatever you like to do, or just to have a good rest, or so, because so far our college is operational, but who knows what they're going to come up with tomorrow on Wednesday, because if they decided to shut it down because of the hurricane, then we're not going to have a class, even though I can run it, of course, but you know, some people may not have electricity, so that's why it might be not a very good idea. So we'll see what happens on Thursday this week. So if everything goes fine, then we will keep working on chapter 7, and otherwise we'll just continue next week working on chapter 7. So I'll let you go today without a quiz. So have a great and safe time, and I guess we'll continue with this. So no worries, we're not going to abandon it. But again, no quiz today. No quiz today. Have a good day.